Good day, Mr. Crawford. We are the Kaleidoscopes, and our team is composed by Jorge, Delfina, Roman, Regina, Julio, and me, Juan. Our technology is a microbial solution for degradation of crop residues. The diagram shows the sugarcane cycle, which takes around 1 year for farmers to harvest the cane. Once harvested, crop waste becomes a byproduct that requires attention. The disposal of this waste is critical in the field's preparation for the next farming season. Disposal becomes a sub-process that demands resources and work. For the voice of the customer assessment, the team performed interviews to experts, farmers, sugar mill managers, engineers, and distributors. We capture the need to remove and dispose crop waste efficiently. For this, we understood in time and cost. So, they could have higher farming area, no plague generation because of the waste natural degradation, and desirably incorporation of organic matter back to the soil. Typical waste disposal is performed by mechanical removal, which is a legal procedure that adds cost to the operation, but turns to be better than burning, which is dangerous and illegal.
Hi, I'm Regina. In this scheme, we present the two main populations that are key part of the sugar farming cycle: heat engineers and farmers. Both evaluate the most common and cost-effective method for crop waste disposal by mechanical means. On the like features for sugar mill managers and engineers, the most are to avoid burning and avoid fines or legal demands due to safety issues, maximize profit reducing costs by the use of fertilizers and labor in case of sugar mill. In the case of farmers, most are also profit through the labor of the mechanical remotion and safety. Also, if we consider that fertilizers are under credit for them, they will also have some benefits for them. On the dislikes, the high score over the most for avoiding plagues. Bottom line, the bottom population suggests a different way to remove waste as Beta San Miguel Corporation that requests something that can degrade straw in situ and faster than it goes, advantageous against mechanical removal as well as legal. Our technology is already at TRL7 and has proof of performance on sugarcane fields. We decide to link this exercise with the voice of the customer based on their needs and pains. Therefore, we consider two function deployment exercise. One, QFD that depict via mean product development named Probios, and the other where the team had the chance to use the tool and provide packing solution as for material and shape with the aim to ensure the product shelf life.
Hello, this is Roman Nava, and I'll be talking about the quality function deployment for the ProBIOS development. As product, needs and features are listed and prioritized by the team. Then, engineering characteristics of the development are grouped and related with each of these customer needs and features. Positive and negative values were given to each parameter in order to make the correlation or conflicts matrix. The team assigned values of 5 for high, 3 for medium, or 1 for low to score the weight of each of the needs with the engineering characteristics. Then, a customer perception between the three considered techniques for crop waste disposal are listed at the right. From all this exercise, we were able to define specifications quantifying in units each engineering characteristic for target Probios product. Some of these features cannot be listed due to the fact that at this stage, Probios is still a trade secret. However, what was available or permissible is listed there. Correlations were strong positive as 9, mild positive and negative 3, and strong negative qualified as 1. And as we may see, there are two lines that are technical importance and technical difficulty. This comes from all the ponderations that we listed for each of the engineering characteristics and their correlations between them. In this way, we get the specifications for Probios. So after all this exercise, the team understands that to develop a product that satisfies customer needs, that could avoid fertile fines due to safety and health, improve organic matter reincorporation to the soil, and improve profit of the sugar mill, we should work on the waste disposal problem in an innovative way. Biomine focused on the bacteria type and the trade-offs to provide an effective degradation product, which ended up with Probios. So in the same way we performed the Probios development exercise as a QFD, the packaging development was taken by the team. So this exercise defined the packaging material that Biomine would target to distribute the product to the end users based on their needs and make the best selection based on the qualification of the correlation between the characteristics for the engineering of the packaging material. So 3 key engineering demands are required by the product: permeability, temperature withstanding, and volume. For the most challenging characteristics, the team considered, based on the exercise, that the mechanical aspect of the container, such as elasticity of the material, being waterproof and no corrodible material, are important to ensure the product integrity. Based on the latter, the team decided to select the plastic as the adequate material for the selected container, as we refer in our diagram and the exercise performed. So again, the QFD also, with all the correlations between the different engineering characteristics, end up with a specification for the packaging material in some units to quantify this. The Probios target packaging were selected based on what is considered optimum for maintain safe as the product safe.
Hi, this is Alfina. Well, Biomin focused on the bacteria type and its concentration to provide an effective degradation product. Specifications were targeted so they could meet COFEPRIS regulation for a vegetable nutrient product, which are solubility, biological efficiency as a degrader, storage stability, and toxicological studies. So one of the main aspects is the bio's shelf life, which is dependent on the packaging and storage conditions. Then the team decided to exercise an optimum design of the packaging. Therefore, when choosing concept generation techniques that would lead to packaging improvements, we decided to start with an intuitive approach using brainstorming and organizing ideas on a mind map. As shown on this slide, we focus on 4 critical functions that represented opportunities to innovate. First, a package that would not affect or could even improve product shelf life. Second, a package that would allow space optimization while transporting and storing the product. And for this distribution aspect, no spillage was also of interest. And finally, because the product was already a green solution, a package could be bio-friendly as well. Some of the ideas we came up to were around the material properties, mainly such as inner porous materials, temperature control, biodegradable and non-toxic materials. One idea that came up in the 4 functionalities was a refill system. But now we needed to see how this would work on a C-sketch.
Hi, this is Jorge. For this sketch, we perform the package form as a model. We use the sketch with different team members and based drawing, we start doing the different changes by individual. Those were shared by email, so we end up with all the sketches modified, and this is the one that is thought by the team to be the most representative of the idea that we would like to bring up as a concept. We use the chart where we list the criteria mainly on the customer needs and what the team thinks to be important, as Biomin perform on the function deployment and the weights by the customer and define the specs on the QFD also. We start making selection with the team to weight and qualify each aspect. At the end we have from the sketch presented before, we have sketch A, B and C. Sketch A is plastic bottles and sketch C is carton bottles. As you can see, the one is preferred is sketch A. When we weight that, we saw that A sketch is superior to the others ones, and that is because in the main more important variables it meets what is needed by as taught by the team. The team thinks that sketch A regarding material and design will meet Biomin's and customer needs, which is a cylindrical bottle made of high density polyethylene with a safety seal.
Hi, this is Julio. Talking about our prototyping strategy and based on the previous exercise, we have selected a bottle that actually meets the performance that Biomin was looking for. The main aim was to provide a solution that was low in cost for both Biomin and the customer. After looking at the specs and design, we finally decided to choose an option that was already off the shelf and was easily available on the local market in such a way that supply will not be an issue. Our insights and conclusions are the following. For most of us, this was the first time we went through this kind of exercise. It was indeed a very insightful one. The main lesson learned was to focus on the packaging material in order to maintain the important bioproperties throughout the lifetime of the product. When we were considering to develop a bottle for the packaging of ProBios, we realized that Biomin have already selected one easily available and low in price at the time they had made the formulation. At the end, we learned that a cylindrical plastic bottle of high-density polyethylene performs the job just fine. However, the idea to give further thermal protection to the formulation of the technology is still considered if a local vendor is available. Therefore, we think we will develop further into this issue. As a conclusion, we now know that we do not need to spend time trying to fix something that is not broken. Nevertheless, if this provides bioamine a significant value proposition, it is definitely worth the time pursuing a solution to preserve the product. Thank you.